Today we're looking at simultaneous equations again, which is lesson 3 of 3. What we want to do now is move on from our first two lessons where we looked at solving relatively easy equations to being able to solve any simultaneous equation. In lesson 1 we looked at how we could subtract two simultaneous equations to go from having two variables down to one variable. We eliminated a variable. We'd then substitute and solve. So this method was subtract, substitute and solve. But we can only do it when the number of c's, say, is the same in both equations. And that is the problem you've got. The method only works when you've got two c's or three c's in both equations. And in lesson 2, we looked at how if we had the same number of, say, w's, we could add the two equations. Again, that would eliminate one of our variables. So this method was add, substitute, solve. So we came up with this idea of DAS, where if we had different signs like we have here, we would add, same signs, subtract. And the DAS method will work, but it only works when the number of variables are the same in each equation. So now we look at something like this, where they're different. And what we then do is we do a very similar thing to what we do with fractions with different denominators. We look at our d's and say, look, I've got two d's here on the top and 3 in. Well, why don't we make equations with 6 d's in them? And we can do this by just multiplying them up. But the trick is we have to multiply all parts of the equation by the same value. So if we look at this one, we want to get 6 d's. So we multiply the top equation by 3. So we multiply the c's by 3, the d's by 3, and the 30 by 3. On the bottom of the equation, we only need to multiply 3d by 2 to get 6d. But we have to multiply the c by 2 and the minus 17 by 2. Once we've done that, we can apply DAS. And remember, different signs add. So in this case, we're going to add the equations, and then we can find c relatively easily. Now what we want to try and do is to find what d is. And what we do here is we make the number of c's the same. And that's very simple because we can simply multiply the bottom one by 2. So I multiply c by 2, I'm going to multiply the d's by 2, and the minus 17 by 2. Then we remember our DAS, same signs minus. Because the c's are both positive, we do a minus, and this way we can find the d. So using our DAS method combined with multiplying the equations up, we can solve any simultaneous equation. So what we've got to have a look at first of all to see, can we apply DAS straight away? If not, we have to multiply our equations up. Then we use DAS, and then we've got a choice. We can either repeat the process, or having found one variable, we can substitute and solve to find the other variable. So finally, it is time for you to have a go. So get your pen and paper ready and write these down. Then pause the video, because then in a few moments, the answers are going to be shown to you. So just pause the video, write down, and away we go. And here are all the answers, and we hope you got them right. If you've got any problems at all, we will look at them in a bit more detail in the one-to-one lessons. So thank you for listening to the video, and the best of luck with your maths this week.